The next subject that we want to talk about is the minimum cost scheduling. Many times we want to shorten the time to complete the project, and this is also what we call crashings. When we try to crash a project, we need to be able to shorten the time for you to complete the activities. And usually when you want to do that, you will need to pay more because you want to invest on the labor or the equipment so everything can be processed at a quicker time. So when we are trying to crash the project, we need to consider the cost. And the project will include two types of costs. The one is called direct costs. Those are the costs directly associated with the activities. So whenever you want to shorten the duration of the project, you need to consider the direct cost. The second type of cost is called the indirect cost. Those are the costs associated with sustaining the project. So it is not related to individual activity, but instead the whole project. For example, it can be the labor or the insurance for some project that you are working on. And before we can start, we need to define a couple terms. The first one is the normal time. That's the normal process time for you to complete the project. We also have the normal cost. So that will be the cost for you to complete the activities under a normal process. So the cost we are talking about here will be the direct cost. We also have the crash time. That will be the shortest time for you to complete an activities. And the crash cost will be the cost associated with the crash time. For example, if you want to achieve the crash time, the crash cost will be the money that you will have to pay. So the maximum time that can be saved will be the difference between the normal time and the crash time. And the cost for you to expedite an activity for 1 unit of time will be equal to the cost difference. So that will be the normal cost and the crash cost divided by the normal time subtracted by the crash time. So you will be able to know if I want to reduce 1 unit of time, how much money I need to pay extra to get the job done. So for example, if the normal time will be 10 minutes and the normal direct cost will be $20, the crash time is 6 minutes and the crash cost will be $40, then the maximum time that can be saved will be 4 minutes. So it will be 10 minutes subtracted by 6 minutes equal to 4. And the cost for you to expedite an activity for 1 unit of time will be 20 divided by 4, which is 5. Because we know we will be able to reduce the time from 10 to 6, and we just need to pay $20 in addition. So $20 divided by 4, that will be 5. So the process is very simple. The first thing you want to do is to find a critical path, because once you know the critical path, you can identify the total time of your project. And also, if you want to reduce the duration of the project, you need to try to reduce the time of those critical activities. That's why it is very important for you to identify the critical paths. Then we can calculate the cost to expedite an activity for 1 unit of time using the formulation on the previous slide. Then we want to pick the available activities from the critical path that has the minimum cost to expedite it. Because we don't want to spend too much money, we want to start from the cheapest one. Then we can calculate the new direct cost for the new schedule. It may lead to a new critical path. If that's the case, you need to recalculate the new critical path. Then you can repeat this process over and over again until you feel that there is no more room for you to get the improvement. So this is a typical example that I can show you how it works. I choose a very simple project because you can visualize what will be your critical path without actually doing any calculations. So in this case, our critical path will be A, B, and D. So we can start from that. The first thing you want to do is to calculate the cost per day to expedite. So we want to find out how will be the cost for you to improve 1 unit of time per activity. For example, for activity A, it will be equal to 4 because I know I can reduce time from 2 to 1 if I spend 4 additional dollars. Okay, so 10 subtract by 6 divided by 2 subtract by 1, that will be equal to 4. You do the same thing, you can figure out what will be the unit cost per activities. You can also find out what will be the maximum days that may be shortened. For example, for A, it can be shortened from 2 to 1. So the maximum day you can activity A can be shortened will be 1. For activity B, it can be shortened from 5 to 2. So the maximum days that can be shortened will be 3. Similarly, activity C will be 1. Activity D will be 2. So originally, my total direct cost will be $6 plus $9 plus $6 plus $5. That will be 26. However, the total time will be the duration for those critical activities. We know the critical activity in this case will be A, B, and D. So the duration will be 2 plus 5 plus 3, which is equal to 10. Now, if we want to shorten the duration of the project, we can try to shorten activity A, B, or D, because those are critical activities. But then we can try to see what would be the cheapest one that we can work on. So we know for A, it will be $4, for B, it will be 3, for C, it will be 2, and for D, it will be 2. C is not on our critical path, so we have to ignore it. So the only thing we can do will be the activity D. Okay? So let's say if I reduce activity D's duration by 1 unit, then the total direct cost will become $7 because original cost will be 5. And if I try to reduce 1 additional unit, it will be $2 additional dollars, so that will become 7. But the total time will become 2. Because original it will be 3. If I try to reduce it by 1 unit of time, it will become 2. So that's why when I try to calculate the cost, the direct cost in this case will be 6 plus 9 plus 6 plus 7, because with the 2 additional dollars, the total cost will become 28. However, the total time will become 2 plus 5 plus 2. Instead of 10, it will become 9. Okay? Then you need to check whether your critical path will change. In this case, our critical path will still be A, B, and D. And we know for activity A, if I try to shorten this by 1 unit, it will be 4, B will be 3, D, it will be 2. So at this point, I can still try to reduce D by 1 unit of time. So when I do that, we will notice that the total direct cost becomes $30 and the total time becomes 8. Then this becomes our new project. And in this case, our critical path will still be A, B, and D. Alright? However, if I try to see the maximum day that can be shortened, you may say that, okay, for activity D, the cost will be $2. I try to reduce D for 1 unit of time. But you cannot do that because D can be shortened by 2 units of time only, and you have done that already. So we actually want to cross out D because you can no longer improve activity D. Which means the only thing we can do will be either activity A or activity B. And B will be cheaper, so that's what we are going to do. We will try to reduce B by 1 unit of time. Which means when B is shortened by 1 unit of time, our total direct cost becomes $33. However, our total time will become 7. And that will be 1 unit shorter than the previous one. At this point, you will realize that my critical path will change. Okay, it will be A, B, D. It can also be A, C, D because both has the same durations. So at this point, it doesn't make sense for you to reduce B by 1 unit of time, because when you try to reduce B by 1 unit of time, ABD is no longer a critical path, which means it will not improve the total duration of your project. If B is equal to 3, the total duration of the project will still be 2 plus 4 plus 1. Similarly, it makes no sense for you to reduce C, because when you try to reduce C from 4 to 3, my critical path will become A, B, and D, and the duration will not change. That means if I want to improve the duration of the project, the only thing I can work on will be activity A. So let's do that. If A is shortened by 1 unit, the total direct cost will become $37, and the total time will become 6 units of time. At this point, you probably will notice that there's no more room for you to do any improvement, because as I mentioned earlier, we have 2 critical paths. So whenever you try to reduce the duration for B or C, the total time will not be reduced. So this is the optimal that we will be able to get. So let's try to see if we can solve a similar problem. And suppose I know my normal time and the normal cost, the crash time and the crash cost. When you see a table like this, the first thing you want to do is to calculate the cost per day to expedite, and also what will be the maximum day that can be shortened. So for activity A, we know the cost, crash cost will be 7, normal cost will be 3, the crash time will be 1, and the normal time will be 2, which means my cost per day to expedite will be equal to 4. And for activity B, my crash cost will be 6, normal cost will be 5, normal time will be 5, crash time will be 2, which means cost per day to expedite will be 1/3. And you can do the same thing for the rest of it. The third one will be 3, next one will be 2.5, and the last one will be 2.5. The maximum day that can be shortened will be the difference between the normal time subtracted by the crash time. And for the first one, it will be equal to 1. Second one will be 3. Third one will be 1. Next one will be 2. Next one will be 2. Okay? Then we can calculate the total direct cost of the original plan. For the original plan, the cost will be everything we see right here. So I will have 3 plus 5 plus 3 plus 5 plus 7. That will be equal to 23. And the total project time will be the time for the critical activity. So we know if the critical path is ACDE, we only need to focus on ACDE, which means the time will be 2 plus 4 plus 3 plus 5. That will be equal to 14. Now, if I try to shorten the duration of the project, which one I should choose? You check the cost per day to expedite to see which one is the cheapest one. And as you can see, B is the cheapest one. However, B is not on our critical path, so we should ignore that. That means if we want to reduce the duration of the project, we can either work on activity D, because that costs only $2.5, or activity E, that will be $2.5 as well. So activity D or E can be chosen. Once we do that, the total cost will become 23 plus 2.5. That will be 25 plus 0.5. So this is the cost. And the time, the durations will become 14 subtracted by 1 unit, which is 13. So this way we know if you spend 2.5 $5 more, you will be able to reduce the total duration from 14 to 13.